tell Paul Fournier he was right. The baggage compartment will not hold 700 pounds. Good morning, my name is Armin Rivard. Have a seat.
Nice to meet you. My name is Ed Lycoming.
Ed, I understand you have a new engine for my lake aircraft.
Yes, we have a new and improved 200 horsepower engine. It's called the IO360.
We are very excited about your new engine here at Lake Aircraft. We expect it to improve the performance of our aircraft to 190 knots.
Mr. Rivard, I don't think my new engine will improve the performance of your aircraft to 190 knots.
Too late. The brochures are already at the printers. Ed, your engine is important to us because we never stop trying to improve our aircraft. Harry Shannon is testing my latest idea for decreasing manufacturing costs. You know how expensive and heavy all those hydraulic cylinders are. Well, this is called our new and improved gravity gear retract system. The gear just falls into a block position. So, Ed, my calculations show your engine should produce 200 horsepower at 14 gallons per hour.
Well, that's not quite true. Yes, 14 gallons per hour produces 200 horsepower, but the engine overheats at that fuel flow.
So, you are trying to sell me an engine that overheats? It had better come with a huge discount.
Let me explain. It doesn't overheat, unless you exceed 75% power, and all air-cooled aircraft engines overheat at full power, but we have a solution.
What is your solution?
We just add extra gasoline.
How does that cool your engine?
Much the same way alcohol feels cool on your skin. The extra gasoline cools the engine from the inside.
How much extra gasoline does it take?
About 30% more.
Why don't you build an engine that doesn't overheat at 14 gallons per hour?
We could, but we already have all the tooling to build this engine for about $2,000 and sell it to you for $25,000. It would cost us much more to build a better engine, and to make the same profit, we would have to charge you more. Not to mention all the years and millions of dollars getting the Federal Aviation Administration to approve it. Even then it would take more time and millions more to get it STC'd for each aircraft.
Okay, but wouldn't the extra saving in gasoline pay for that?
Mr. Rivard, let me ask you a question. Do you pay for the extra gasoline?
Well, no, I don't.
Neither do we.
Okay, now it's beginning to make perfect sense to me. But I have one more question. The engine requires 30% more fuel when operated above 75% power, but how about below 75% power?
Below 75% power the engine does not require the extra gasoline to cool it, if the aircraft is in cruise speed.
Okay, that's not too bad, if it only uses the extra gasoline during takeoff and climb.
Well, that's not true either. You see, the Bentix fuel injection system was designed before we had the technology to determine when the engine is producing less than 75% power, so the Bentix fuel injection system always adds extra gasoline whether it is needed, or not.
Isn't there anything we can do to stop this waste of gasoline? It is cutting into the 2,000-mile range of my aircraft.
Of course, the pilot can adjust the fuel flow to the engine independently if he wants to, by using the mixture control.
But what if the pilot chooses to take away the extra gasoline when it is needed to cool the engine?
He will damage the engine.
I have an idea. Why don't we use a computerized fuel injection system that can automatically adjust the fuel flow like the one in my car? Hans, call our supplier Ace Hardware and order a computerized fuel injector. Mr. Rivard, no one makes an alternative fuel injection system. Why not?
The Federal Aviation Administration would not allow it. They would say it is unsafe until we spent millions and years to get them to say, it's safe. Even then, Lake Aircraft would have to spend hundreds of thousands and years to get it approved for their aircraft.
Surely, the Federal Aviation Administration would recognize how important this is for general aviation and help us get this on our aircraft in record time.
I'm afraid you don't know them very well. We say their motto is, We are not happy, until you are not happy.
Okay, so how can a pilot be sure they are not damaging the engine with the mixture control?
Once in cruise power, that is, 75% or less, there is nothing they can do with the mixture control to damage the engine.
Are you willing to put that in writing?
We already did. Our president produced a publication that we have online, that states that. It tells a pilot how to manage his fuel flow with the mixture control.
That's great. Hans, you know that brochure that states our aircraft has a range of 2,000 miles. Throw those in the trash and print some more with 2,500 mile range.
Here is the publication I was talking about. On page 38, I'd like to call your attention to this paragraph. This is what it says. First, we must know that cruise power for Lycoming normally aspirated engines is generally considered to be 55 to 75% of the maximum power for which the engine is rated. At these power settings, the engine may be leaned at any altitude. There has been some confusion about the reference to not leaning below 5,000 feet density altitude. Remember that reference only applies to those power settings above cruise range. Those normally used for takeoff and climb. Once cruise power has been set, leaning to best economy should be standard procedure, as damage to the engine will not occur from leaning at cruise power settings.
Okay, Ed, I like what you are saying, but how can a pilot know what percentage of power his engine is producing?
That's easy. All a pilot has to do is refer to this chart in the engine operator's manual.
Are you joking? This thing is so complicated. You would have to be an engineer to read it.
I see what you mean, but basically most people run their engines 24 squared and at sea level that works out to be about 70% power. At 70% power they can move the throttle and mixture control to any position without harming the engine.
There's got to be an easier way. I'd have to have Paul Fernie with me all the time to read the chart.
Well, here's an easy chart. Lycoming didn't publish it, but since I am a cartoon character, I can't be sued, so I'm going to share it with you. Notice the chart has manifold and RPM settings for 75% power, and the same for 65% power, and 55% power. It also has altitude setting, and this chart matches the one in the engine manual, but is simpler to read. It also gives instruction for how to adjust for temperature changes.
We will have these available, free, in the back, to all. Ed, why can't I purchase a device that would just tell me the percentage of power the engine is producing?
Well, of course you can. Here's one that is legal to install in your aircraft.
That's great. Hans, put this on our list of options. When pilots are choosing options like airspeed indicator or altimeter, be sure and mention this instrument. Okay, so I know I can lean my engine using your chart without damaging it. But can you tell me about lean of peak?
Wait just a minute. We have to be careful. We are entering a very delicate area. Up to now the Federal Aviation Administration has allowed modern data to be displayed in the cockpit, such as the one pictured here. This data is available to pilots, but the Federal Aviation Administration believes, if this modern data should find its way directly to the engine, in the form of a new fuel injector, it could cause a tear in the time-space continuum, and would cause the Federal Aviation Administration to implode, causing a boom in general aviation. Since that would be contrary to all government oversight, the government would collapse. So, even though this instrument provides all the information to control the engine, in order to save the government from collapse, the pilot must process the information and apply it to the engine controls.
Wow, I had no idea.
Well, there, Sonny, the Federal Aviation Administration don't take kindly to anyone messing with our money. You know, we get a percentage of every dollar spent on aviation gas. What's your name?
John Smith.
And what's your name?
Oh, me. John Staber. I think I left my plane running.
I'll be keeping an eye on you, Don't let us catch you trying to modernize no certified aircraft.
Is he gone?
Yes, I think he's ramp checking that elderly couple.
Oh, I think I saw them handcuffed on the ground next to the plane.
Let's get back to our conversation. That said, I have to explain a few basic things. First, it takes 15 gallons of air to completely burn 1 gallon of gasoline at sea level. If you remember, the engine burns about 30% more fuel than it needs, unless you lean the engine with the mixture control, so unused gasoline is wasted out the exhaust pipe.
Yes, and that fuel is not needed in less than 75% power, so it can be removed by leaning in cruise power.
That's right. By leaning to best power in cruise, the pilot can save money on fuel.
And I have Lycoming's guarantee that I can lean to best power at cruise without damaging the engine.
Yes, you have that in writing. The only downside is the engine runs warmer.
Does that damage the engine?
No, as long as it doesn't exceed 440 degrees cylinder head temperature. Now we can talk about lean of peak. Lean of peak is a method of adding extra air, but not increasing to the amount of fuel going into the engine. The fuel only needs 15 gallons of air to burn a gallon of gasoline, so the extra air cools the engine just like the extra gasoline does.
Okay, I understand, but how do I adjust the mixture to accomplish lean of peak?
First, we have to redefine everything you thought you knew about the controls in your aircraft. Can you tell me what this is?
Of course, that's the up and down lever.
I beg your pardon, did you say up and down lever?
Yes, you push that forward, the engine makes more noise and you go up. Pull it back, the engine gets quieter and you come down.
Well, maybe you needed this lesson anyway. Do you know what this is?
Of course, that level makes the engine quieter, but doesn't make the aircraft go up or down.
Interesting. How about this lever?
That's easy. It turns the engine off and on.
Let's start with this lever. Most pilots consider this to be the power lever, but it's not. The engine is a giant air pump, sucking air into the engine anytime the propeller is moving. This lever is attached to a valve that controls how much air is sucked into the engine. The manifold pressure indicates how much air is actually getting into the engine. The higher the manifold pressure, the more air the engine takes in, to prove that the manifold pressure has nothing to do with power. Watch this video. The pilot will set the engine at 24. He will turn the mixture to off, but the manifold pressure doesn't change. The lever pictured here can change the manifold pressure, but the engine is not producing any power.
Wow, who knew the manifold pressure wasn't power? So that means one of those other levers controls the power.
In lean of peak mode, that's correct. I'm going to explain this in very simplistic terms. This is not exactly how the system works, but it will be easier to understand. Imagine a bathroom sink with two faucets or valves that allow hot and cold water to be mixed together. Now picture this. Pretend the hot and cold water valves to be air and fuel valves. The two valves are connected together. When the air valve is opened, the fuel valve is opened as well, allowing a ratio of fuel and air into the engine.
Okay, I understand, but isn't that ratio 30% more fuel than the engine needs?
That's right.
So how does a pilot adjust the fuel ratio?
We added another separate valve in the fuel line. called the mixture control. This valve allows the pilot to reduce the amount of fuel going into the engine, without reducing the amount of air.
Isn't that a very primitive system?
Whoa there, Mr. John Staber, I've been listening, and I don't want you boys calling our regulations primitive. Are you sure your name is John Staber? I just busted a guy named John Staber in a weird seaplane for using his nose wheel as a bumper. Listen here, if it wasn't for us, you boys would be using all that newfangled modern stuff those experimental boys use, saving dollars that should be coming to us. We just can't have that, and I don't want to hear no more of that kind of talk. I gotta go. I see a scratch in the paint on the wing of that plane over there. Hey you, flyboy, get on the ground. Are you trying to take off in this an airworthy plane?
I'm beginning to dislike that guy.
You are not alone. Now let's get back to our lesson. So what would happen if we open the air valve all the way in cruise, and then lean the mixture with the mixture control?
You would be controlling the power with the mixture control, instead of the manifold pressure.
Exactly, power is controlled by gallons per hour, and the temperature of the cylinder head is controlled by the manifold pressure. This is lean of peak operation.
That's all there is to it. Why are so many people saying lean of peak will damage the engine?
Like Homing has stated in writing, there is nothing you can do with the mixture controls at cruise power to damage the engine, so lean of peak cannot damage the engine, but engine damage could result if the pilot changes altitude or power settings without monitoring the cylinder head temperature. For that reason, like Homing doesn't endorse lean of peak. We don't forbid it, but for liability reasons, don't endorse it, and lean of peak is not for everyone. It will not work on carbureted engines. And some pilots don't feel comfortable adding to their workload.
Okay, let's say I want to run lean of peak. I just push the up and down lever all the way forward and then move the mixture control lever.
It's not that simple. You will need some extra equipment to make sure you don't damage the engine. Now here is where it gets technical. To run lean of peak, you will need these GAMI or equivalent injectors. This allows each cylinder to receive exactly the same amount of fuel. Also a JPI or equivalent instrument to measure fuel flow, exhaust gas temperature, and cylinder head temperature for each cylinder.
Great, I will add this to my list of options. Plus, I can charge extra for teaching pilots how to use them.
When a pilot has a fuel flow meter, like the one pictured here, he can determine what power the engine is producing by gallons per hour. Once he has determined how many gallons per hour produce 75% power, he can leave the throttle, or as you call it, the up and down lever, at fully open, and adjust the power, using the mixture control. In this next video, you will see that power is determined by gallons per hour only, and changing the manifold pressure only increases or decreases the cylinder head temperature.
What are we doing in here?
I thought we would finish up our discussion, where prying eyes can't see us. I thought I would tell you, Federal Aviation Administration rules might be changing to allow modernization to our aircraft.
Now you've gone and done it. Trying to change the rules and make more work for us. Listen here. The FAA don't want no efficient airplanes out there using less fuel and cutting into our money. We got it just the way we want it, and the only change you are gonna see is a mandate to install ADS-B.
Yes. But at least we get weather and traffic with that.
You boys are more stupid than a piano player in a marching band. That is just a surveillance gadget. Do you know what the boys at the office call ADS-B? Airplane, drivers, surveillance. And the B is my favorite, busted. Traffic and weather. It's just a little Vaseline, so it won't hurt so much. Don't expect any positive changes. For you fly boys, we're gonna keep it just the way we want it. Don't count on no modernization. In this lifetime, you got yourself an uphill battle.
I think I've heard enough of your superior attitude. Aren't you supposed to be supporting aviation, instead of hindering it? I think you should have a conversation with our attorney.
Whoa, partner. Better men than you have sick attorneys on us.
We have an attorney that purchased a late aircraft. His name is Pete Hartman. He is flying in today. In fact, I think that's him in the pattern now.
Wow. I can't ever remember an attorney being this effective.
I have to admit, that was impressive, but I wonder if Pete needs work on his final approach.